Well, hello students, welcome back to Math Specialist class with me, Mr. Alfie. In this video, we're still going to learn about application of factor. One of the application of factor is to solve a physics problem about equilibrium system. Let's check this video out. What is exactly equilibrium system is? Okay, equilibrium system, let's jump to the example. This is a weight that held by two ropes in certain angles. The picture represents a weight of 100 newtons suspended from two ropes. The ropes are attached to the ceilings and hold the weight at different angles as shown. As you can see in this diagram, if this weight is held by these two ropes and it not moving, it means this is what we call equilibrium system. Assuming that the system is equilibrium, it means the weight is still not moving and these two ropes can hold this weight. Assuming this is the original point, we're gonna figure out the acting force that work in this system. The first force is this force in this direction is 100 newton. This is the force represented by this 100 newton weight by gravity. And then the next force is F2, that this is the component of F2. So this is the I component of factor F2, and then this is the J component of factor F2. So for this component, for I component, it actually the adjacent of the angle, because this one is equal to this factor. So in this component of F2, the I component is F2 cosine 60. In this component, the J component is actually opposite of this angle. So F2 equal to sine 60. The next force as act in this system is F1. This force. So we can write F2 as a component factor. This one, the I component factor of F1, and this force is J component of F1. So this is the opposite and this is the adjacent. For I component, F1 cosine 40, and for the J component, F1 sine 45. If we collect all the force that act in this system, it will be this one. So equilibrium system, it means not moving. In other way to say it, it means all the force that acting in this system equal to 0. It means the factor that act in this way to the right is actually equal to the force that acting in that way to the left. So the right equal to the left, and also the forces that acting in that way upward equal to the force that acting in this way downward. That's why you call equilibrium. All the force equal to 0. So find two equations from the factor diagram given, one along the x-axis and one along the y-axis. This is the x-axis and this is the y-axis. Let's figure out the x-axis first. Since this is equilibrium, it means the force acting that way equal to the force acting in this way. So F1 cosine 45 equal to F2 cosine 60. So we just find the value of cosine 45 and cosine 60. A half of f squared of 2f1 equal to a half of f2. F2 equal to square root of 2 of f1. This is the first equation in x-axis. How about the y-axis? Remember, this is equilibrium. It means the force that act in that way equal to the force that act in this way. So since there are two factors that act in that way, we add all those factors together. F1 sine 45 plus F2 sine 60 equal to the weight. We substitute the value of the sine. So a half of square of 2 times F1 equal to a half square of 3 F2 equal to 100. The weight is 100. Okay, we multiply by 2 this equation, we will find square root of 2 f1 plus square root of 3 f2 equal to 200. This is the second equation that represents the act force in y-axis. Next, determine f1 and f2. In order to find the value of f1 f2, we just need those equations that we have found before. So f2 equal to square root of 2 f1. We substitute this value of f2 in this equation, in this one. So square root of 2 f1 plus square root of 3 multiplied by, we substitute the value of 2, square root of 2 f1 equal to 200. Just simple multiplication, we find that square root of 2 f1 plus square root of 6 f1 equal to 200. So square root of 2 plus square root of 6 multiplied by f1 equal to 200. So f1 equal to 200 per square root of 2 plus square root of 6. By your calculator, you will find that the f1 equal to 51.76 Newton. How about f2? f2 equal to square root of 2 f1. So we have found the f1 equal to 51.76 Newton. So f2 equal to square root of 2 multiplied by 51.76. We will find that the value of f2 equal to 73.2 Newton. If the weight is 100, this is the value of f1 and f2. Next, if the ropes can support a maximum tensile force of 17 Newton each, what is the maximum weight that can be suspended in this setup? Okay, let's assuming one of the ropes work in a maximum tensile. If F1 is a maximum, it means F1 equal to 70 Newton. So F2 equal to square root of 2 times F1. So if F1 equal to 70, F2 actually equal to 98.99 Newton. This is more than 70 Newton. From the equation, we know that the maximum from each is 70 Newton. So this system is not as we expected because F1 is more than the maximum. We can't use these numbers. How about the other possibility? F2 is a maximum. So the value of F1 is actually equal to F2 per square root of 2. If F2 is 70, the maximum, so F1 equal to 70 per square root of 2. F1 equal to 49.5 Newton, less than 70 Newton. So this is what we expected. If F2 is maximum force, so F1 is 49.5 Newton, is less than the maximum. We will gonna use these numbers. So we have found the value of F1 equal to 70 Newton and the value of F1 equal to 49.5 Newton. Now we're going to find the weight that can hang based on this force. So since we are going to find the weight, it means we're gonna need the equation in y-axis. So this is the equation in y-axis. F1 sine 45 plus F2 sine 60 equal to the weight. So we have found the value of F1 and F2. So the weight equal to a half square of 2 times 49.5, the value of F1, plus a half multiplied by a square of 3 times 70, the value of F2, equal to the weight. So by your calculator, you will find that the weight can be suspended if one of them is a maximum tensile equal to 70. It's actually 95.62 Newton. That is the maximum weight can suspend.